In this next portion of the lesson, we're going to talk about differentiability at a point. The reason I separated it is because you may refer to these separately from the indeterminate forms that you just saw as part of your homework. Differentiability is very similar in idea to continuity. Again, we're talking about at a point. A function itself may have times where it is not differentiable. However, there will be times in which it will be. So when we talk about differentiability, we're talking about it at a point, not as a whole. So what we're looking at graphically then is that it is smooth. The graph is smooth. There is no jagged edges. There's no jagged points. We can determine the slope, okay, at and near its point. One of the things that might help is when you're thinking about drawing tangent lines, because we're talking about derivative here, that we would be able to determine where that tangent line would rest. What I mean by that is, when you look at this particular example that you have in front with the two lines coming together, does the tangent line come from this direction? Does it come from this direction? Or is it like this? Because the point is, it is not differentiable at that point because it has that jagged point. And we cannot distinguish where that tangent line would be drawn because this would be tangent, this would be tangent, and so would this and countless others. So we have to be very careful when looking at these and saying, okay, is it smooth? Yes. No, it isn't. When we're looking at these, it's not talking about continuous, where we're not picking up our pen, but rather no jagged edges. That's what we mean by smooth. And so there can't be any doubt as to whether there is a derivative that exists at and near this point. We can determine where that slope of the tangent line would be. Remember, derivative and slope of a tangent line is the same. So this one is not differentiable at this point because it has that jagged edge and we cannot determine its derivative. Similar to this one here, although it looks smooth, again, where is that tangent line coming from? Is it coming from here or is it coming from here? And so because there is that discrepancy, that jagged edge, this also is not differentiable. Along this graph that you see here, similar to e to the x or an exponential, any point along this, we can determine its derivative. It is in fact smooth. There are no jagged edges, so this would be a yes. Again, when you look at this next question, we want to look for, is it smooth? Can I determine the slope of a tangent line throughout the entire graph? And of course, yes, the answer is, so that would be differentiable. The trick about this next one, and it is an exception to the rule, because yes, it looks smooth, but it is not an exception when we're talking about derivative, because as you look at this analytically, there are times that, you know, okay, smooth, that's good enough. But the truth is, that misleads you on this particular question, because although it is smooth, it is not derivative. It does not have a derivative at every single point. Where that spot would have a vertical tangent line, that would have no slope or no derivative. And therefore, this is not differentiable as a function. Now, again, along this graph, sure, it's differentiable here and here and here and here and anywhere along here. And even at times as we're coming around the curve here. But once you get to that point in which the derivative or the tangent line has no slope, then it eliminates it from being differentiable as a function. Okay? So vertical tangent lines, even though the graph appears smooth, it is not differentiable. Now, a function can be continuous. So much like you see in this first graph here, it is in fact, this is in fact continuous, but it is not differentiable at all because of that jagged edge. It's not smooth. If a function is not continuous, then it cannot be differentiable. If there's any break, then the function as a whole is not differentiable. Okay, because of that break, it's not differentiable.